Alright, so some of the things we know about metals. They are shiny. That means they have luster. They can be made into a wire. They are malleable. That means they can be bent or bendable. They are good conductors of heat and electricity. And they have high melting and high boiling points. Obviously, I even talked about STP, which means standard temperature and pressure. So when we're talking about these properties, we are talking about standard temperature and pressure. The temperature and pressure that we are at right now. Okay, we have not heated anything up. We have not cooled anything off. All right, properties of nonmetals. They're the opposite. Nonmetals are dull. They are brittle. Kind of think of them like plastics. Plastics, if you bend them too hard, they're going to snap. You're going to get that nice snap to it. You're not, can you not see it? Your nonmetals are not going to conduct heat. They're not going to conduct electricity. Like a piece of wood would be a poor conductor, or silicone would be a poor conductor. And they have low melting and low boiling points. Most of the nonmetals are going to be gases at STP. Not all of them, but a lot of them. So while you're copying that down, I know. Hold on a second. Just wait 1 second. I just want to get the reference tables up here. I'll put it back in a second. All right, there you go. Yet.
Rob, show me his boss.
You're the boss, Rob?
No, yeah, he's the boss. That's what he says to me.
Nope. Are you the boss or is Carl the boss?
Okay, good, Rob?
Yeah.
Okay. So if we look at the periodic table, which I'm going to grab right now, and we look at it, there is a line here. See this little line? This dark black line? It's the staircase. It separates the metals from the nonmetals. Which side are the metals on? The left. There's one element that is not a metal that's on the left. Which one is it? Hydrogen. Good. All right, and then we have our nonmetals. So you'll notice that the nonmetals like nitrogen, oxygen, fluorine, chlorine, and all the ones in this last column right here, these are gases at STP. So there's quite a few of them that are gases. And that's because they have such low melting and boiling points. That means at room temperature, we have already reached their melting or their boiling points. Also, we're going to point out on this table S, which is the table after your periodic table, they give you your melting point and your boiling point of certain elements. So if you look at oxygen, it melts at 54 Kelvin and it boils at 90 Kelvin. That says 90, right? Did we talk about Kelvin yesterday? Did with one of my classes. All right. Okay, I'm going to change it in a second. Okay, so Celsius. Okay, we're good. We're good. Degrees Celsius and Kelvin and Fahrenheit. All right, so if we're looking at water, What temperature does water freeze in Celsius? 0 degrees. And what about, actually let's do let's do Fahrenheit. 32, good. Okay, what about Kelvin? You're close. It's 273. Okay, now, this is the formula. If you look at the back of your reference tables, the very last page, okay, I'm not going to bother to flip this, but it's right here at the very bottom. See where it says Kelvin equals Celsius plus 273?
Yes.
Okay, that's the formula to go from Celsius to Kelvin. So Celsius plus 273 equals Kelvin. If I have 0 degrees Celsius and I add 273 to it, I'm going to get 273 Kelvin. I want you to notice that when you move up 1 degree Celsius, you also move up 1 Kelvin. They are the same size, just a different scale. And the reason why we're going to use Kelvin most of the time is because there are no negative values. The lowest Kelvin value is absolute 0, which everybody loves because we're like, ooh, absolute 0, it's really cold. Absolute 0, 0 Kelvin, that's as low as the temperature can go. Okay? All right, what temperature does water boil at in Celsius? 100 degrees Celsius. And what temperature does it boil at in Fahrenheit? 212. Crazy. Okay, now what about the Kelvin one? 373. That must have been what you were thinking about before. Okay, so this is the... Why are you guys talking? You got something you want to say? Okay. Alright, I want you to put a star next to this because this is very important. When we are measuring temperature, we are actually measuring the kinetic energy of the atoms. What does kinetic energy mean? Energy of motion. So, a temperature is equal to the average kinetic energy. Anytime you see the words average kinetic energy, you can just simply replace it with the word temperature. Kinetic means movement. So we take the movement of all the atoms that are in the sample, and if we have that, it is equivalent to what the temperature is. So sometimes they'll ask this. This is always a fun question. 90 degrees Celsius, 323 Kelvin, 45 Kelvin, and 500... that's too high. Let's do 135 Celsius. Which one has the highest average kinetic energy?
135 Celsius.
Okay? So what we have to do is we have to change them all to the same unit. Let's see if Kevin's right. So we're going to change them to Kelvin. Could just as easily change the Kelvins to Celsius. But let's change the Celsius to Kelvin. So we're going to take the 90. We're going to add 273 to that. We're going to end up with 363. 135 Celsius. We're going to take 135, add 273 to it. 408 Kelvin. Now that we have all of them in the same unit, now you can tell me which one has the highest average kinetic energy. This one. Okay? Because all I'm asking you is which one has the highest temperature. It says average kinetic energy. It's simply just temperature. That's why I want you to put a big star next to this. Because sometimes they ask a question, you think it's a hard question, and it really is a very easy question. All right, any questions on that so far?
No.
Okay, metalloids. Did I use that word yesterday?
No.
Okay. Metalloids, also called semimetals. I have it written right here, so I don't have to rewrite it. Okay. Basically, a semimetal has properties of both a metal and a nonmetal. So it may be shiny, but it might not conduct electricity. It might be dull, but it might conduct electricity. So there are things that are not quite metals, not quite nonmetals. They are in between the metals and the nonmetals. Okay? And I'm going to show you where they are. They are going to be on the staircase. I'm missing Jack and Jake today. Knock moved over. Okay. So, you want me to go back? Mm-hmm. This is me when I play ping pong. I get like all crazy like. My eyeballs go like this. Okay. We good? Alright. These are my semimetals. Boron. Just look for a second. You're going to be coloring them in on your own periodic table in a little while. Boron, silicon, arsenic, tellurium, and astatine. So, can I... Here's my staircase. Okay. Here are my semimetals. And germanium and antimony. Those two. So all the ones that are sitting on the stairs, and germanium and antimony. Polonium, in some books they say yes, it's a semimetal. Some books they say no. Aluminum is a true metal. Do not say that aluminum is a semimetal. You know what an aluminum can is or an aluminum foil. That's a real metal. That's not a semimetal. Okay? And then all of these.
What about PO?
PO, depending on what book you're reading, but the Regents does not classify it as a semimetal.
Will you even be using it?
Nope. We will not. So you really need to know the ones that are sitting on top of the staircase.
Okay. You don't even care about the ones that are like below 40, right? Like, you don't have to care about them.
These two?
Like the ones that are like below 40, like the elements.
Below 40?
Like you don't gotta care about the elements as much, right?
What are you talking about?
Like the ones below atomic number 40, like, you don't gotta care about them.
Below? Like lithium?
Like higher, I guess.
Yeah, well, we use them infrequently. We'll use tin.
Okay.
We'll use lead. We'll use mercury. We'll use gold. But most of these you'll never see.
Yeah, you don't need to care about them.
Okay? You really need to know like up to 20. And then the ones in the beginning of the year that I told you are really important. Like iron and copper and zinc.
Okay.
Those are the ones you're going to see 99% of the time. Okay. Solids. Most of your periodic table are solids. Okay? Here's your periodic table. Most of them are solids. It's going to be very apparent which ones are solids in about 2 seconds when I show you the liquids. Okay? There's only 2 liquids. They are mercury and bromine.
Isn't mercury also a solid?
No. Mercury at STP. Remember, I'm always talking about at standard temperature. Can I make mercury a solid? Sure, I could cool it off, but then we're not at standard anymore. Okay? Bromine is another liquid at standard temperature and pressure. Kevin? Okay? And then the gases are over here. Okay? So we've got these 4: nitrogen, oxygen, fluorine, chlorine. hydrogen, and all of this last group are your gases. So there's 4 here, 1 over here, and these, and you're going to be coloring them in on your periodic tables. I'm going to give you a big periodic table tomorrow, and you're going to color it in. All right, last thing for today. Something called a diatomic element. They are elements because, you can hear my voice is starting to go. They are elements because there's only one of them. Let me explain something to you. If you have a box, and in that box I have these particles, this is classified as an element. Okay? That could be any element you want. This, however, it's too green, is not an element. This is a compound. What's the difference between this and this? The element is a pure substance. Okay? And usually I start the year off talking about pure substances, but it works here. A pure substance is something that there's only one thing in this box. Anytime you reach your hand into that box, you're going to get that element. That's a pure substance. Here, you have a compound. When I reach into that box, I'm always getting a compound. I'm going to get a green and a red every single time I reach into that box. These are both pure substances, but this one is a compound. What's the difference between the element and the compound?
Compounds like multiple different elements combined.
Say that again, loud and proud.
Compounds like multiple different elements combined.
Good. 2 or more different elements that are bonded together. So a compound is going to be 2 or more different elements. This one, however, is an element because there's only one. Now look at this. What do you think that is? It's an element, okay? Because it's not different. These are still elements. There's a special type of element called a diatomic element. What's the prefix di mean? 2. Atomic, atoms. 2 of the same atoms that are bonded together. And there are 7 diatomic elements that you have to memorize. And here they are. Okay? Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. Okay? Hold on one second. I'm going to show you how to remember them. You ready? How many diatomic elements did I tell you there were? 7. Listen very carefully. What is this atomic number? 7. Okay? Look at the shape that they make. 7. I know. It's crazy, right? Okay? So now, if you count these, there's only 6 here, right? Where's the 7th? 1. The 7th 1 is hydrogen. Okay? That's how you can remember what your 7 diatomic elements are. You're going to start at the number 7. You're going to make a 7. And your 7th one is going to be hydrogen. There is also a funny word to remember it. Brinkelhoff. It is a funny word. I do not know where that word came from. I did not make that word up. But if it makes you happy, you can write down Brinkelhoff and you will have your 7 diatomic elements. You like Brinkelhoff? That should be my password, shouldn't it?
Now you know the next word.
I don't know. Secrets.
I didn't make a Wordle this week, did I?
No.
It's not safe because I just told you what the password is. The password is Brinklove. You know what? I could put the 2's in there. It would be a very secure password. All right, so just one more time. You now know your solids, your liquids, and your gases. Again, you might not know them by heart, but you kind of can see what's happening. We have solids most of the time. We've got 2 liquids, and we've got gases. We have our 7 diatomic elements. You know that we have metals and nonmetals. Where the heck goes my picture? Okay, here's your metals. I can erase this. Metals are going to be on the left side of the staircase. Here's your staircase. Nonmetals are on the right, and your metalloids are the orange ones. Okay? I will post this PowerPoint so you have it on your Google Classroom. That way you can look at it tomorrow when you start coloring your periodic table in. And then you'll know which one's which. Any questions on those things? All right, I'm done talking.